Hello and welcome to this MagiCAD for Revit webinar. My name is Hemmo Määttänen and I'm going to highlight a few features for you in the 2025 main release, covering mechanical and electrical features and a couple from the common tools. On the mechanical side, we have today the long anticipated dry systems sprinkler calculation and a couple modeling related new features and improvements. On the electrical side, we have the possibility to add system classifications on electrical systems. And on common tools, there's now some extra flexibility in terms of turning rooms in a linked IFC file to spaces in a Revit project. This feature included as part of the Project Wizard tool. And last, the new view selection in real-time class checking. So let's go. Let's begin by taking a look at the products that are used in sprinkler dry networks. So we have here, when it comes to valves, in other valve category, we have here a valve product, a dry valve, and here in dataset properties, we have to also, for sprinkler calculation, define this valve as a dry valve. Also, we can define the equivalent lengths for this product. For sprinkler heads, we have some generic products here available with characteristics for dry sprinkler purpose. And I have here an example network, a pump here, and the dry sprinkler valve, as well as the sprinkler heads here. In Revit, when it comes to the Revit system classification, so even though it's a dry calculation, so even though this is about dry system calculation, from Revit perspective, it is still a wet system. And for dry sprinkler calculations, we need a pump and the valve. And when we go on and install the valve, we can here, when installing, define some of the characteristics here for the valve. Opening pressure ratio, accelerator, the delay time, and the activation pressure drop. And here we can also see those characteristics here in the instance parameters. So the design area is made in the same way as before, nothing new there. But the calculations, we have now the specific dry sprinkler calculation section here. So what we do here is we can run the calculation either for a water source or a pump. So if we begin with the water source here, we define the curvature and the diagram and the fluid characteristics for the water and for the gas used in the system and its characteristics here as well as the time step and warning limits and so on. The standards work as before, so they define the equivalent lengths for components. We click on OK, and first we get the generic results here. So here we have some dry sprinkler specific values here at the bottom, the transit and delivery time and the air trip time here, as well as the volume of water accumulated to non-open branches. If we scroll up a bit, here we can see the gas used in dry section, temperatures, pressures, and the accelerator information that we defined. Otherwise, the sprinkler results and system results are the same. And here we can see the water source diagram and where the operational point lands in relation to the diagram. We can also run the calculation using the pump. So let's do that. And here we can see the pump, the system curvature and the pump curve. So this is how the dry sprinkler calculations work in a nutshell. We might have a situation where we need to resize our pipes or ducts in some other way than running the sizing, which normally also sizes the components. But if we have an uncompleted network, we might not be able to run the sizing, but we still want to change the pipe or duct size. So then the component sizes stay the same. So that's why we have implemented a so-called component sizing. And if we go to the dataset to see some of the pipe series settings here, so here we have a valve size and zone valve size defined for each pipe size. So therefore, when we run this component sizing, we get the MagiCAD sizes the components according to the pipe series settings. So we could, for instance, take the current view and see what happens. So now in this case, the tool finds available sizes for the components, and it is possible to size the components according to the new pipe size. And this tool is available also on the ventilation side. When we're going to install piping components, such as back boxes or stop valves, we can use the new installation method, which we have added here, this smart installation. So for instance, I have here a shower with a connection pipe and the angle bend here where I would like to install a back box. And I might also have material, the pipe material changing here in between. So with this smart tool, I can now install angled components right away to the bend, simply by selecting the bend like this and accepting. So this is something that speeds up the modeling process. Another example is the stop valves, and here we can do the installation in plan view as well, but here we might have to change the display style a bit to wireframe so that we can see the return pipe there. So in the same way, we go to install product, and this time we take the stop valve category and select the angled component that we want to use and take the smart installation. And here we can select the component and it gets installed there. And apply. For electrical systems, we've had the MC system code and system name parameters, but now we have added parameters also for system classification classes. And let's go to the dataset to see where these systems are managed. So to begin with, we have electrical systems here, and here under the variable settings, we have a system classification codes now for electrical systems as well as for communication and data. So if we take a look at the electrical systems, system classifications, we can here see, for instance, the electricity distribution systems. This is a uniclass classification as an example, but of course these classes are fully user modifiable. And we can here go, for instance, to the highest hierarchy here and map all the systems for electrical systems, MagiCAD electrical systems to be used. So once we have done this, we can go back to the electrical systems here and then apply or assign a system classification code to our systems that we have defined here in the dataset. It's done here in the system classification codes. Let's click on the three dots here, and here for sockets, we could, for instance, select a low voltage distribution system and click on OK. And here, if we need to create several classification codes, once we have done one, we can take a new copy of selected. So it's maybe speeds up a little bit of creating new classification codes. And as you can see so far, the parameters here are empty, but we'll go to update parameters here, select electrical, and down here we have system classification code. So once we run update, let's say for the whole project, and click on OK. So MagiCAD updates those parameters for product instances, and we can see here the classes, types, and codes getting updated according to the system that we set. And when we create new, or when we install new products and we select the systems here, the main systems here, we do not have like the system classification selection here in the product installation, but when we run update parameters, MagiCAD updates the information for all the products. Let's begin right away by linking the IFC model into the current project. I will just reload it from here. And when we are linking an IFC, it's important to keep in mind that the internal origin point is the one according to which the alignment is happening, regardless of what the coordination point was when this architectural model was exported. So now I have it here, and we can also take a look at the elevation view here. I have my levels here from the current project. They match with the ones from the IFC. And here we can also see that the internal origins match. So what we can do now is we can go to Project Wizard, a tool that reads the rooms or spaces from the link. So let's click on the copy from link, and we are now in the first floor. So we could now, for instance, take the first floor as an example. So now MagiCAD will create the spaces according to the rooms that we have in the link. We'll click on OK, and we'll get a notification that 26 new spaces were added. We'll click on OK and apply, and the spaces are created. And here we can see also the updated area. So let's close the window here. And here actually you can see these dashed lines here. They are space separation lines that are needed to create the spaces like this from using a link. And here the spaces are. We can also go to a section view to see the spaces here in the first floor. In this project, we have a specific view for clash checking. Right now, I'm in a plan view, in a working view, and if I want to have control over clashes when I'm doing the modeling, I can now select here in the clash settings a specific view for those real-time clashes. So let's click on the real-time clash on and select the view where we want to present those clashes. So let's take, for instance, this 3D clash checking view and click on it like this. And let's restrict the categories here a bit. Let's put like piping against piping and click on OK. Let's not run the actual clash checking now, but the real-time clash is sufficient right now. So I'll just click on OK. And obviously in this, even though there are clashes, nothing happens in this view, but I have here the 3D clash checking view open. And here we can see that the clashes are highlighted with the red boxes here. And now if I want to tile the views, I can do that. For instance, when I'm doing a very detailed modeling and a coordination is needed, then I might want to have these views tiled. And here you can see that the real-time clash works as it should now. But it doesn't bother me in this plan view if I don't want it to.